Hey everybody, Mr. Reeves here with you, and I am in IXL where we are being asked to add and subtract numbers written in scientific notation. So hopefully you all got a chance to watch my previous introductory video on learning how to add and subtract scientific notation. Just a reminder that the powers of 10 must be the same if it's going to work. If they're not the same, you must make them the same by rewriting the coefficient. Once the powers of 10 are the same, then you simply add or subtract, depending on what the problem is asking you to do, the coefficients, and you keep the powers of 10 the same. All right, so if we take a look at this first problem, luckily for us, the powers of 10 are the same. So here we go. So we've got 7.72, right? And I'm going to subtract 2.10 because it is a subtraction problem. All right, 2 minus 0 is 2, 7 minus 1 is 6, and I get 5.62. And remember, the powers of 10 stay the same. So 5.62 times 10 to the 6th is the answer that I am looking for. Look at that. We are super. All right, so once again, the powers of 10 are the same. 5.84 plus 2.85. So I'm going to go 5.84 plus 2.85. I'm going to add those together. 4 plus 5 is 9. 8 plus 8 is 16. Carry the 1, and we get 8.69, right? 8.69, and the powers of 10 stay the same. So 8.69 times 10 to the second power is what we are looking for. All right, and that's right, Mr. Reeves. Okay, here we go. Once again, I think one last one will do where the powers of 10 are the same. It's a subtraction problem. So I'm going to go 9.50 minus 4.06. The powers of 10 are the same, so we can subtract the coefficients because it's a subtraction problem. I'm going to have to borrow. 10 minus 6 is 4. This becomes 4 minus 0 is 4, and 9 minus 4 is 5. 5.44. The powers of 10 stay the same, so we get 5.44 times 10 to the ninth. All right. So as you can see, and you should have already known, hopefully, when the powers of 10 are the same, then all you do is add or subtract the coefficient. All right. Make sure when you're done, your answer is in scientific notation, which I'm seeing now. It might be good for me to actually do this problem here because the powers of 10 are the same, but something's going to happen this time that hasn't happened before. When I go 7.0 plus 4.7, what do I get? I get 7, and then 7 plus 4 is 11. So my answer is 11.7 times 10 to the second power. Well, wait a second. That's not any of my answers, right? And the reason it's not any of my answers is because that is no longer in scientific notation. If you watch my previous video, the last step of my notes was rewrite your answer in scientific notation if needed. It never happened up till this moment. So what does this number have to be? Do you remember? It has to be greater than or equal to 1, but less than 10. So 11.7 is too big. So I'm going to change this to 1.17. What did I just do? I just moved the decimal once that way, right? But that means I made this number 10 times smaller, right? So I have to go like this. I have to change this to times 10 times 10 to the second, right? If you make the coefficient 10 times smaller, you must make the power of 10 10 times bigger. And now what do I have? Not 10 to the second, but 10 to the third power, okay? So this time, that's what we got. All right, so let's see if that's going to happen this time. No, not going to happen there. Let's skip up to, oh, we can't go up to another level. we still have ones that are the same. I was hoping to get to one that was different. Well, let's do this and maybe we'll get one that's different. So the powers of 10 are the same. So I'm going to go 6.63 minus 5.90. Okay, when I do that, 3 minus 0 is 3. I'm going to have to borrow here. 16 minus 9 is 7. And this becomes 5 minus 5, which is 0. Ooh, interesting. I get 0.73 times 10 to the, what was my power? 7. But again, that's none of my choices because this is not written in scientific notation. So what do I have to make this number? It has to be bigger than or equal to 1, but less than 10, right? So that means it needs to be 7.3. But I just made this, right? I just made this one 10 times bigger. So this has to be times 10 to the negative 1 power. Isn't that kind of weird, okay? I made this one 10 times bigger, so I have to make this part 10 times smaller. So I get times 10 to the 6th power. So again, if you make this one smaller, like in the previous problem, in the previous problem we made it smaller, so this part got bigger. We made this 10 times smaller, so instead of 10 to the second, it were 10 to the third. This time we made it 10 times bigger, so this one went from 10 to the seventh to 10 to the sixth. Coefficient gets bigger, power of 10 gets smaller. Coefficient gets smaller, power of 10 gets bigger. So 7.3 times 10 to the 6th power. All righty. No, they still don't have one that's different. How many of these are going to make me do? This is insane. All right, here we go. That's what you're probably thinking when you have to work through them, right? 2.4 and 4.87. They're both powers of 10 to the 8th, so we can add these together. We get 7. 4 plus 8 is 12. Carry the 1. We get 7.27 times 10 to the 8th. The good news is we didn't have to change anything this time. That was our first choice. All right. They just don't want to give us one with different powers of 10. Wow. Do you think my whole video was wasted? All right, here we go. 6.1 plus 4.980. Here we go. 8 plus 0 is 8. 1 plus 9 is 10. Carry the 1. 6 plus 4 is 10. I get 11.08 times 10 to the what power? 4th power. Is this number in scientific notation? No, it's not. It must be greater than or equal to 1 and less than 10. So I'm going to change it to 1.108. I moved the decimal back one place. I made this 10 times what, ladies and gentlemen? 10 times smaller, so this one must get 10 times bigger, right? So it's 10 to the first times 10 to the fourth, which is 10 to the fifth. If you make the coefficient smaller, the power gets bigger. If you make the coefficient bigger, the power gets smaller. 1.108 times 10 to the fifth power. Oh my goodness. Well, I'm thinking maybe they're not going to have us do one that's different. I'm going to do one more. I could have swore that there was ones on here where they were different. All right, here we go. Subtraction problem. 9.40 minus 8.73. Here we go. We're going to have to borrow, right? 10 minus 3 is 7. We're going to have to borrow again. 13 minus 7 is 6. 8 minus 8 is 0. So we get 0.67 times 10 to the ninth power, right? That's what our powers were. They stayed the same. Is this number in scientific notation? No, it's not, right? It has to be between 1 and 9. It could equal 1. I get 6.7. Boys and girls, did I make that bigger or smaller? I made it bigger, so this one has to get what? Smaller. How many times I move the decimal place? 1. This must get 1 smaller. 6.7 times 10 to the 8th power. All right. Oh my goodness. Woo. Finally. I knew it was coming. Look at that. Finally, question number 8. Or maybe it's question number 9. I've already done 8. Finally, there is one that is different. 9 and 7 are not the same, right? So I need them to be the same. And if you watched my video, my recommendation was choose the bigger one. So 1.46 times 10 to the ninth is going to stay. And I need to change 9.6 times 10 to the seventh. And I need it to be what? I need it to be 10 to the ninth, right? So what do I have to put here? I have to put 10 to the second here. Do you guys agree? 10 to the second times 10 to the 9. All right, I just made this what? 100 times bigger. I just moved the decimal 2 places to the right. So what do I have to do here? I have to move it 2 places to the left. If you make the power of 10 100 times bigger, you must make the coefficient 100 times smaller. If you make the power of 10 100 times bigger. I changed it from 10 to the 7th to 10 to the ninth. This moves it 2 to the right. So to balance it out, I have to move it 2 to the left. So what does that give me? 1.46 minus 0.096. All right, here we go. Gonna have to borrow. 10 minus 6 is 4. All right, this is 5. Gonna have to borrow again. 15 minus 9 is 6. All right, and I already borrowed, right? So this, wait, no. So this was a 4, now it's a 3. So I get 0.3. Sorry, I get 1. I didn't have to borrow there. Sorry, I'm getting a little tired, guys. 1.364 times 10 to the ninth power, right? Because we made it 10 to the ninth power. Look at that. There was only 1. That's how I knew I made my mistake. I looked up and saw it was 1.364. All righty. Okay. All right. One last one. Here we go. Once again, the powers of 10 are not the same. My recommendation, take the smaller one and make it bigger. So I have 10 to the fourth, right? But what do I want? What do I want, boys and girls? I want 10 to the sixth. So what do I need here? I need 10 to the second power, right? 10 to the second times 10 to the fourth is 10 to the sixth. So what did I just do? I made it 100 times bigger. So what do I have to do with my 1.5? My 1.5 must get 100 times smaller. This moves it 2 to the right. I have to go 1, 2 to the left. Okay, so I get 0.015 times 10 to the second. So now I have 5.3 minus 0.015. I think that's correct. 0, 0. Here we go. I'm going to have to borrow. 10 minus 5 is 5. Going to have to borrow again. All right, so this is going to be, so wait, this became a 9. My apologies. So this is now a 9, right? Okay, that can go away. So 9 minus 1 is 8. All right, 2 minus 0 is 2, and 5. Okay, please be there. Oh, good. I do not recommend doing math when you are tired. Okay, 5.285 times 10 to the what? We made it 10 to the sixth power. 5.285 times 10 to the sixth power. All right, so to summarize, all right, you must make the powers of 10 the same. If they're not the same, I mean, they have to be the same. If they're not the same, my recommendation is take the smaller one, right? And say, what do I have to multiply by to get the bigger one? So I want 10 to the 6th, right? Because this one is 10 to the 6th. So to make this one 10 to the 6th, I had to multiply by 10. But that means that the number that you had, since you made this part 10 times bigger, this part has to get 10 times smaller, right? So make the coefficient the same amount smaller as you made the exponent bigger, or vice versa, okay? And then once the powers of 10 are the same, you can add, or in this case, subtract the coefficients, okay? It is a little tricky. The good news is multiplying and dividing is easier, all right? Until next time, when we multiply and divide in scientific notation, have fun. Good luck. See you later. Bye.